Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I'm Facility Coordinator, Event Planners for the Redmond Reactor Space. And before we get started today, I've got a few things to go over. So if you could please take a moment and check out our code of conduct. Basically, what that is saying is that we seek to provide respectful environment for both our audience and our presenters. We encourage engagement in the chat. But we please ask that you might be mindful of your commentary, remain professional, and if possible, please remain on topic. Useful links will be shared throughout the chat, so keep an eye out for that. And we want to let you know that this session will be recorded and be available on demand in about 24 to 48 hours on the Microsoft Reactor YouTube channel. Our session today will run approximately 1 hour, and there'll definitely be time for questions throughout. So with that said, I will now hand it over to our speaker for introductions. And Anders, it looks like your content dropped off.
Yeah, I'll bring it back. So it should be on now, right? There we go. Good. Yeah, welcome everyone. For the next half an hour, we'll dive into Azure Verified Modules and some of the values in that and all the things you can do about it. But before going there, I just want to introduce myself. My name is Anders. I'm working for Supersteria as a director in our Cloud Journey department. And I'm also Microsoft Azure MVP on the 10th year. So I've been working with this Azure space for quite a long time. And you can basically talk with me about anything in the Microsoft Cloud, but I'm especially interested in the Cloud Journey parts, of course, the adaptive cloud, and of course, Microsoft Azure, which will be a huge part of today's session. So the session will be about how to do smart and efficient infrastructure as code, right? And in that one, I will then dive into how to do that with Azure Verified Modules, which is fairly new, but already quite well adopted and well used out there. And I really think that solves a lot of the pains for customers and organizations. So the main parts of this session will be on Azure Verified Modules. But to be able to understand the value behind Azure Verified Modules, I also want to set a bit of context and diving into, just briefly though, Cloud Adoption Framework and Well-Architected Framework, because I think those are important to be aware of to be able to understand why Azure Verified Modules is such a good thing to start adopting. And then to just make sure that everyone is on the same page when we dive into code a few minutes from now, I also want to briefly touch on infrastructure as code and what that is, and also Microsoft Bicep, which is the domain-specific language I will be using when demonstrating Azure Verified Modules today. So with that, I'll just dive in. If you have any questions as we go along for the live audience, that is, feel free to just ping them in the chat, and I will go and look at the chat from time to time to ensure that we actually have them answered. And if you are looking at this as a recording, please don't hesitate to ping me on LinkedIn or anything, and I'll definitely help you getting your question answered on Azure Verified Modules. So with that, I'll briefly touch on Cloud Adoption Framework and Well-Architected Framework first, and both are free to use and available at learn.microsoft.com. And I think, and they are also developed by Microsoft and community and all the organizations using Azure. So it's a set of best of breed recommendations when it comes to adopting Azure and also building good solutions on Azure. So beginning with Cloud Adoption Framework, it is a framework used to make sure that the organization is ready to take on using cloud solutions. So it will help you go all the way in defining the strategy for how to use it, planning how to adopt it, making sure that the whole organization is ready to actually start using it, and then also help on how to adopt. And as a part of this, if you are able to follow at least some of the recommendations from CAF, you will get a organization that are ready to deploy workloads into cloud, both in a secure way, have a good management on everything, and also have the governance in place to be able to operate the solution over time successfully. And another part that are central in Cloud Adoption Framework is establishing teams that are helping you build things correctly in cloud, and then also including infrastructure as code, which we will also demonstrate a bit later on how a cloud adoption team and cloud platform team, cloud automation team are able to work together to make sure that you get the best Azure infrastructure as code deployed using Azure Verified Modules. Another quite important framework to have in mind is the well-architected framework, which gives you guidelines and recommendations on how to architect cloud solutions, especially in Azure, correctly, and making sure that you have thought about everything related to reliability, security, cost optimization, operational excellence, and also performance efficiency. And another reason for lifting cloud the well-architected framework in this session is because Azure Verified Modules drives towards being compliant with the recommendations in well-architected framework. So by using Azure Verified Modules, a lot of the resource you're deploying is already compliant towards how well-architected framework recommends services to be deployed. So with that, I'll also quickly lift a sample application of how a well-architected solution might look like. And this reference architecture is basically showing how a app service in Azure should be deployed to be able to handle everything from security to availability and so on. And there's a lot of components in this architecture that are complex to understand, for example, for a web application team, because normally they want to focus on just writing the code for the application and making sure the website is looking good, not having to think about virtual networks, application gateways, securing secrets in the application, making sure that you have good connectivity between the app service and the database. Normally, they just want to have that up and running, right? So there's a lot of components here in this solution that are making infrastructure as code complicated to adopt for organizations. So before diving into Azure Verified Modules, I also want to just quickly touch on infrastructure as code and also Microsoft Bicep. So infrastructure as code is basically a way to get version control of your infrastructure. So everything from databases to network to web applications to web servers to storage accounts, all of those kind of resources can then be defined using a language like Bicep and stored in a version control system like Git, for example, which will then give you, of course, increased consistency and reliability in the application, because you can have a lot of governance controls on the code that actually are being deployed to Azure for the workload that are going to be run. It also enables you to do automated testing and of course automated deployment of resources to Azure by using infrastructure as code. And maybe best of all, you will get documentation for the workload out of box, instead of having to write a lot of documentation in Word, for example, or updating drawings and so on and so on. So by using Bicep and Azure Verified Modules, you will get a lot of this for free. So with Microsoft Bicep, which is the domain-specific language I'll be using in this session, it is a language that is really easy to understand and learn and get started with. And it also supports all the features in Azure from day one when it comes, because it's developed by Microsoft, it's open source, and it's well connected to all the product teams in Microsoft. So you don't have to wait for an update to be able to start using a resource type, for example. It's also stateless, so all the state of the resources are then handled inside of Azure, which is a huge benefit. So you don't have to stand up additional environments to be able to handle the state for the solution, and it's completely free as well. Another key feature in Bicep is the modules, which is also the reason why we are able to have something like Azure Verified Modules. So a module in Bicep is basically a collection of resource code which can be referenced in a file and then used to deploy the infrastructure way faster. So with that, I'm going to dive a bit into Azure Verified Modules on an introduction level, but first I'll just quickly check if there's any questions in the chat. No, there's no one as I can see. So if you have any questions as we go along, feel free to just post them in there, and I'll try to adjust the presentation thereafter. So Azure Verified Modules is an initiative driven by Microsoft and is fully open sourced. So at aks.ms/avm, you will find a lot of documentation on what it is and how to start using it. But I think the most important things to highlight here is that it is until now at least, a really successful initiative on defining how good infrastructure as code should look like. So in Azure Verified Modules, there's a lot of specifications on how modules should be written, how they should be governed, what kind of security settings they should have, and so on and so on. And all these are tested by the team before it's made available in the public Bicep repo. Another huge benefit of having Azure Verified Modules is that we finally have a shared specification on how things are written. So bringing in new developers in teams to start writing infrastructure as code and so on is way easier when everyone has the same pattern for how to write code. And another thing, it defaults to align to Azure to develop architecture framework by default. So by using the modules, you will also have a lot of the best practice security settings set on resources. So Azure Verified Modules is built up by 3 different module types at this point. So you have resource modules, which is smaller module packages, which is built for one purpose, and that's deploying their resource in the best practice and the best secure way as possible. So for example, storage accounts is a resource module in Azure Verified Modules. And when you deploy that storage account, which I also will demonstrate in a few minutes, you will also have that storage account configured with the best practices, security settings, and easier interfaces to enable monitoring, for example, and private endpoints, and so on and so on. Pattern modules, I can actually take utility modules first. Utility modules is fairly new into the project. It's a module that holds a set of tooling for writing best practice Azure Verified Modules. So for example, types for different resource types are available in utility modules today, which really simplifies how to interact with modules. These 2 are then built into pattern modules and can be used in pattern modules, which holds a set of different resources packaged optimally to have a workload deployed to Microsoft Azure. So a typical example here could be a web application with an Azure SQL database and a key vault, like we saw earlier. And by using that pattern module, the developer team can then much easier actually get that code deployed into the solution. I also have a simplified demonstration on that in a few seconds. So there's a question here, if I would recommend using Terraform over with AVM or upscale to Bicep only and utilize AVM. Okay, no. So AVM modules is available both in Bicep modules and also Terraform. So and both is open sourced. So you can use Azure Verified Modules in your Terraform code as well from day one. So for example, a huge Terraform project that recently was upgraded to use AVM is the Azure Landing Zone Accelerator from Microsoft. So that whole Terraform module is now using Azure Verified Modules in the backend to actually get those deployed. So there's no reason to switch to Bicep to be able to use Azure Verified Modules. I'm just using Bicep today because that's the language I know best, and most likely won't introduce any failures in the demonstrations afterwards. So when these modules are built, they will be transformed into a regular Azure Resource Manager template and then deployed into Azure through the Azure Resource Manager. So everything is open sourced, and it comes with a well-thought set of specifications and guidelines to how to actually use it. So I highly recommend go and check it out. So next, sorry, my voice is breaking up here. So I'll now go in and look a bit at how to use Azure Verified Modules in your day-to-day life. And that can easily be done in already existing code, regardless if you're using Terraform or Bicep, by just referencing the br/public endpoint in your module. It's similar code for Terraform. If you go to aks.ms/avm, you will find guidelines on how to use this with Terraform as well. Sorry for the voice. I just had a cough last week, so I'm kind of breaking up here, but I'll try to survive. So a typical pattern for how to use this is by just tapping straight into Azure Verified Modules and the public available registry at Microsoft Artifact Registry. So by referencing BR public in the code, you will actually go to the Microsoft Artifact Registry, pull down the module into the source system, and you will be able to start using it. So when you then build the template, regardless if you're using Bicep or Terraform, it will then use the module at the Artifact Registry if using Bicep, or if you're using Terraform, the Terraform registry. So it's fairly straightforward to start using. And another nice thing about this, since it's a open source project, the developers can also feedback and improve the modules, either the Terraform module or the Bicep module, by creating a pull request to the source repo in Git. So if you find a bug or you find a feature that are missing or something similar, you can then easily go and help improve the module for further use in the future. So I highly recommend looking at how to contribute as well. If you start using AVM, it will save you a lot of having to write everything from scratch, right? Another quite common pattern we see when starting using Terraform is using it in an inner source scenario. So in this scenario, a cloud platform or automation function in the organization will use the public modules to create private modules and host them in an internal available Bicep module registry. This pattern allows you to have modules available for the developers, which is tailored, custom built for the organization, having additional best practices that you choose to have instead of only having the ones from Microsoft instead. So this is actually a quite common pattern that we are starting to see, and it's a good first step on making custom patterns, which is not in the AVM registry, available for developers. Another pattern that we are starting to see in a bit more security-focused environments is that the cloud platform or automation function in the organization are building new models and only making them available through a private module registry for developers to use. So this makes it even more secure because the organization have full control on the source code all the way into the workload, in opposite of having the public endpoint available for developers as well. So with this one, developers can choose to use modules either from the AVM team or modules from a private cloud platform automation team, versus only from an internal team that are developing the modules. Another pattern that are also starting to surface in organizations that have extreme high security requirements and not exposing the build pipelines to anything at internet, for example, is to configure cache in the Azure container registry, or aka Bicep module registry, which will actually cache the module from the artifact registry onto the Bicep module registry instead. So all the connectivity and connections are happening towards an IP address and endpoint that the organization are fully controlling. I also step in and demonstrate how that works in a few seconds. One of the latest, most super private secure patterns that we're seeing, which takes a lot of effort, is also inner sourcing the complete registry from Bicep. So in this case, all the Bicep modules in the public repo is published by the tag to internal registry, and in addition, a corporate platform automation function or team are developing private modules and publishing them into the Bicep module registry as well. So this makes sure that all code that goes into the workload has been reviewed by a cloud platform function. But this requires a lot of work, and I would highly recommend trying to get this one implemented first with the cache or just the public repo, or even better, finding the trust level in using Microsoft's public modules instead. So that I'll dive into showing some code. So let's see. Before that, let's check if there's anything in the chat. Yeah, I see Brett is commenting a bit. That's good. So let's see. Let's bring up some code and look at how this actually can be in real life. So I'll start off by showing a typical ARM template. So this is how you would write the code for a storage account in Azure in the good old days using the ARM template, which is basically a JSON file. While if you do that using Bicep, it's way simpler. You can see the number of lines of code that you have to have control on is dramatically reduced, right? And you just have to set a few configuration items to be able to have the storage account deployed. In Bicep AVM, it's quite similar, but we are then referencing a module instead, and that module is hosted in the public repo in this case, and then referenced with the account name, and then a version. So all Bicep modules are tagged by a version number in the public repo. So if a new version comes, you can then simply upgrade to a new version by switching the version number. So in this case, I had version 14.1, which was the version for storage accounts back during a night timeframe. And we are today on number 017.3. So that's all you have to do to upgrade the version number for the storage account and have it deployed to Azure. So if you look at what happens in Azure when deploying a resource like this, so this is a storage account by default settings deployed into Azure, which is the source code I showed in this ARM template here. This is the minimum set of settings that you have to configure to be able to deploy a storage account into Azure. So in this case, you will get the storage account nice and fine, but you want to have all the best practices from security, for example. So by default, the storage account will be publicly available from any networks. And if you look at, for example, the encryption settings, you want to have infrastructure encryption enabled on the storage account. If you're using the opinionated version from Azure Verified Modules, you can see that it has enhanced security settings set by default. So the storage account is only available from selected networks. And for example, also encryption is enabled by default on the infrastructure encryption feature in storage accounts. And this is, I think, one really nice important feature in AVM, because this is one of the settings that you, for example, cannot change after the storage account has been deployed. So already here, AVM is helping developers and infrastructure developers to have the security best practices enabled by default. And this happens because in the Bicep modules and the Terraform modules, the default value for the setting on the storage account is set to enabled in this case. But it's of course possible to control using parameters when deploying the storage account. And if we take that step a bit further and look at the pattern I had with a team of, I can bring up the presentation again to just show it. The pattern we had in this case, where a platform function has developed a module to be consumed by an application team and made it available in the private registry. So that I have in this demo here. So let's close this file and clean up the screen a bit. I have maybe a bit uncommon pattern. It's most for demonstration purposes, but in this case, the organization's platform and innovation function has created a module, deployed it to a Bicep module registry for usage, and when a application team are using it, it will deploy a virtual network with a subnet and a storage account with a private endpoint. So if we are looking back at the larger reference architecture from well-architected framework, it's essentially the code for this part in the solution, the storage account with a private endpoint connected to a virtual network. So the code for this looks basically like this. So the platform team, aka me in this case, have used the VNet module in the public repo to configure a set of minimum configuration, which is the subnets, the address prefixes in the network, and also the location and the VNet name. And I've also configured the storage account, given it a name, set a fixed SKU name because I want to have the cheapest storage type available, but I also want to have public network access disabled entirely. And by default, it should connect to the VNet's first subnet. So when this is created, I will be able to publish that one into the Bicep module registry, and it's available in the Bicep module registry, which essentially is a Azure container registry hosted in Azure. So this way, I'm able to have resource control and version control on patterns in the organization. So when the application team is then going to use this, all they need to do is reference the code this way with pointing to the container registry and the path to the storage account that are being used. Seems like I have restored wrong file, so this should actually be BR private, and then let's see, AVM. Let's see if I can fix this on the fly. It should be BR. Oh, come on. Please bear with me. Let's see. Oh, sorry, I haven't pulled down the latest version on this one. So let's work this. Control set. So in the Bicep configuration file, you can configure this one to be aliased. So in this case, it's in another demo I have online. This one is referencing to the container registry and the path and the module online. So they're resolved again. So this module is now pulled down from my container registry and ready to be used. So the only things that the application team needs to give is the account name and the VNet address space, which can then be done in the Bicep param file. And in the end, the deployment would then look like this. So if I go back to my Azure portal and deploy this, you can see that the storage account is popping up together with a virtual network and a private endpoint connected to that network. So this basically removes a lot of the configuration details that an application team needs to think about when building the perfect application workload in Azure. So with that, I think we can start looking at the last part of the presentation, which is the summary for how to actually use and do Azure right. So I would definitely say you should start looking at the Cloud Adoption Framework early to be able to make sure that the organization is ready to have a function like the Cloud Platform team available, an automation team available, and then also have a good look at well-architected framework to be able to do smart and intelligent and efficient architecture in Azure and well-architect infrastructure as code, not at least. When you have had a look at that one, take a look at Azure Verified Modules. It's publicly available on aka.ms/avm. And all the source code is open source and available on GitHub as well. And from there, start looking at Azure landing zones and make sure that you have a good landing zone architecture in the organization. And of course, if you're large enough, make sure also to have subscription vending on everything you do. So that brings us to the half hour, which was actually booked today to go through Azure Verified Modules. Let's see if there's any new questions on chat. No, I don't see anyone. So if there's no questions, I think we are on time, and I can probably say thank you. So if you have any more questions and want to dive deeper into Azure Verified Modules and the capabilities of Azure Verified Modules, please don't hesitate to contact me. I'm happy to do a one-to-one and bring you up to speed on how to contribute, for example, to Azure Verified Modules as well. And also make sure to check out the community sessions that were recently broadcasted on Azure Verified Modules. Everything is available on aka.ms/avm. So thank you.
All right. Thank you, Anders. That was a great session. And thank you for all of you who have joined us for today. We would love to hear what you have to say. We're always looking for feedback. So if you can take a moment and complete our survey, we would be ecstatic about that. The key thing on this is you want to reference the event code for today's session, which is 24955. Once again, that is 24955. Thank you all so much, and we will see you next time.